This episode is brought to you by Triple Automation. Imagine watching $100,000 just sort of vanish into thin air, literally in the blink of an eye.
Oh man, yeah, that is a terrifying thought for any business owner.
Right. And the crazy part is you can't hear anything break. You can't even see what caused it. But a single microscopic airborne spore just landed in a batch of life-saving medicine.
And that is it. Game over.
Exactly.
Well.
That entire production run is immediately compromised and it goes straight into the incinerator. So, welcome to the deep dive, everyone. Today, we are looking at the incredibly unforgiving world of cleanroom manufacturing.
It really is a completely different universe of stakes. We're so used to this traditional image of manufacturing being this loud, sparks-flying environment.
Yeah, totally. Built for, heavy, blunt force productivity.
Right. And in those standard environments, a stray particle of dust or, say, a microscopic droplet of moisture over in the corner, that's just part of the scenery. The line keeps moving.
Okay, let's unpack this. If a standard factory is kind of like a busy diner kitchen where, a dropped napkin on the floor really isn't the end of the world, a pharmaceutical clean room or a high-grade food facility is like performing open-heart surgery.
Oh, that's a great way to put it.
There is absolutely zero room for error. Because the regulatory bodies, like the FDA, they do not care if you are a massive multinational conglomerate or just a specialized local startup.
Nope. The standard for sterility is exactly the same for everyone.
Right. And that brings us to the actual mission for this deep dive. Today, we're exploring how Triple Automation has engineered this curated ecosystem of collaborative technology.
Which acts as the ultimate shield against contamination.
Exactly. Specifically giving small and medium enterprises, the SMEs, the power to actually meet those zero-tolerance standards.
Yeah, and to understand how they built that shield, we first have to understand why standard robots fail so spectacularly in these environments.
We really do, right.
Oh, absolutely. When you move into high-stakes deployments, the entire engineering conversation completely pivots. If you look at traditional robotics, the bragging rights were always about payload and speed.
Like how heavy is the car chassis it can lift?
Right, and how many milliseconds does it take to move it? But in a clean room, all of that takes a backseat. Automation here is no longer just a strategy for raw volume. It is strictly about material integrity, sterile compliance, and absolute precision.
Okay, so we have to look at the biggest threat to that sterile compliance.
Yeah.
And the sources point out this really fascinating irony here.
Oh, the human element.
Yeah. The most dangerous element in any clean room is actually the human workforce.
Biologically speaking, we are an absolute nightmare for a sterile environment.
We really are gross, aren't we?
We are. Humans are incredible, adaptable workers, sure, but we are essentially walking, breathing particle generators. We shed somewhere between 30,000 and 40,000 dead skin cells every single minute.
Wait, 40,000 every minute?
Every single minute. And we naturally carry microscopic pathogens. Every time we exhale, we introduce moisture and unpredictable thermal variables into a space that is quite literally designed to eliminate those exact variables.
And usually at a massive capital expense, I might add.
Exactly.
Yeah.
Millions of dollars spent just to keep our germs out.
Let me push back here, though.
Yeah.
Because the concept of taking humans out of the equation sounds great for sterility on paper. But we are focusing on small and medium businesses today.
Right.
SMEs generally don't have massive dedicated IT departments or whole teams of robotic programmers on staff.
No, they definitely don't.
So if you pull the highly adaptable human out of the line to quarantine the product, aren't you just replacing a biological contamination problem with a massive, highly expensive programming headache for these smaller companies?
See, that is exactly why Triple Automation doesn't just use standard industrial robots. They utilize what are known as cobots, or collaborative robots. And that distinction is vital to answering your question.
Okay, how so?
Well, a traditional industrial robot is blind and dumb. It just moves from point A to point B, and if a human or a delicate piece of machinery is in the way, it will just crush it.
Yikes. So that's why you see them in those massive steel cages.
Exactly. They require heavy safety cages and incredibly complex programming to keep them isolated. But a cobot is fundamentally different. It is equipped with these highly sensitive force-limiting sensors. So if it bumps into an unexpected obstacle, even with the lightest touch, it instantly stops.
So it's aware of its surroundings, in a sense?
Mechanically aware, yes. And because of that inherent safety, you don't need the massive safety cages. You don't need to, rebuild your entire facility footprint to house them.
That saves a ton of money right there.
Huge amounts. And furthermore, the programming isn't done by writing thousands of lines of code. You can literally grab the arm of the cobot, physically guide it through the motion you want it to perform, and the software learns the path intuitively.
Oh, wow. So it's like a teach by touch kind of thing.
Exactly. It is designed specifically for that plug-and-play accessibility, allowing an SME to deploy a highly advanced automation shield without needing a team of PhD engineers on payroll.
Which isolates those critical, vulnerable stages the sources talk about. Things like secondary packaging, fluid handling, kitting processes.
Right.
And it does it without bankrupting the manufacturer. But that leads us to the next massive hurdle. We've painted a picture of an environment that is highly specialized.
It's extreme, yeah.
Right, so taking the human out of the equation is great, but the machinery replacing them now faces a brutal new reality.
The washdown.
Yes. How do you put a highly sophisticated computer, which is essentially what a cobot is, into a room that gets subjected to industrial sterilization without it just short-circuiting in 5 minutes?
You're hitting on environmental resilience, which is really the very first technical barrier to entry. The conditions inside a clean room or, say, a food-grade washdown station are grueling. It is a battlefield.
I can imagine.
We are not just talking about wiping things down with a damp cloth. A standard washdown protocol involves aggressive, caustic foaming agents, and these are specifically formulated to eat away organic matter.
So they're basically acid.
Pretty much. That foam sits on the machinery, then it gets blasted off with high-pressure, high-temperature water. Sometimes we're talking water pushing 80 degrees Celsius.
Wow. And what actually happens to a standard robot in that kind of environment?
Oh, it gets destroyed rapidly.
I bet.
Yeah, the caustic chemicals basically strip away the standard lubricants in the joints. Then the high-pressure water forces its way past the standard rubber seals, and it just short-circuits all the internal wiring, optical encoders.
So it's ruined.
Completely. Within weeks, sometimes even days, corrosion sets in, sensors fail, and the robot just becomes a $1 million paperweight.
Okay, so electronics, extreme heat, high pressure, and caustic chemicals are a catastrophic combination.
Yep.
How exactly does triple automation solve this? Because the sources mentioned they deploy a very specific piece of hardware for this, right?
Yes, the JAKA Pro series Cobots.
Right, and those boast an IP68 rating. Now, most of us know IP ratings from our smartphones, like maybe an IP67 or IP68 means my phone can survive falling into a swimming pool.
Right, excellent.
But an industrial washdown station is a far cry from a swimming pool. What does IP68 actually mean from an engineering standpoint in this specific context?
It's really helpful to break the rating down. So IP stands for ingress protection. The first number, the 6, means the unit is entirely dust-tight.
Okay.
It is completely sealed against incredibly fine microscopic powders. In a pharmaceutical setting where you might be mixing powdered compounds, this ensures nothing can grind its way into those highly sensitive mechanical joints.
And the 8.
The second number, the 8, means it is protected against continuous, complete submersion in liquids, even under pressure.
So how are they achieving that? Because clearly they aren't just like wrapping a standard robot in a plastic bag.
No, exactly. In the old days, the solution was actually to build these complex, cumbersome protective enclosures around the robot.
Like a robot spacesuit.
Yeah, kind of. But with the JAKA Pro series, the robot itself is its own impenetrable enclosure. The engineering relies on aerospace-grade sealing techniques.
Oh, wow. Aerospace grade.
Yeah, you won't find standard exposed fasteners or screws where water can pool up and bacteria can cultivate. The internal wiring is routed completely through the sealed core of the arm.
That makes sense.
And the joints utilize these really specialized gaskets that are designed to expand and maintain an absolute seal, even when they're subjected to intense thermal shock.
Thermal shock, like going from a freezing room to boiling water.
Exactly, like going from a cold room environment to suddenly being blasted with 80-degree hot water.
So they don't just endure the environment, they're specifically engineered to thrive in it. You can literally blast this robotic arm with caustic chemicals and hot water, and it just shakes it off and goes right back to work with absolute precision.
Precisely. It's incredible. But here is the critical pivot in the automation ecosystem. A perfectly sealed robotic arm, an arm that can survive a chemical bath, is really only half the battle.
Right, because at the end of the day, That sealed arm has to actually pick up the product. It has to touch the life-saving medicine or manipulate the fresh organic produce.
Exactly.
A perfectly clean arm is completely useless if the hand doing the touching is compromised.
What's fascinating here is exactly that point, the crucial handshake between the machine and the product. In food and medical processing, the tool touching the item, which we call end-of-arm tooling, must meet the exact same rigorous sterile standards as the arm moving it.
Because if it doesn't, what happens?
Well, if you attach a standard industrial gripper to an IP68 rated arm, you have broken the entire chain of sterility. The system is literally only as clean as its dirtiest component.
Which brings us to the second half of Triple Automation's curated ecosystem. They don't just hand an SME a JAKA Cobot and, wish them luck finding a compatible sterile gripper on their own.
Right, that would defeat the purpose.
The sources highlight a certified partnership with a company called OnRobot. Triple Automation integrates OnRobot's highly advanced food-grade end effectors and vacuum grippers directly into the platform.
And the material science behind those OnRobot grippers is really a masterclass in fighting a microscopic battle.
How so?
Well, when you are dealing with sterility, the physical texture of the materials is everything. Standard industrial grippers often use basic rubber compounds, or they have exposed metallic elements with tiny natural imperfections.
Right.
But OnRobot utilizes exclusively FDA-compliant materials. And these are specifically designed to have perfectly smooth, non-porous surfaces at a molecular level.
And we really need to pause and emphasize why those non-porous surfaces matter so much. I always like to visualize this on a microscopic scale.
It's the best way to think about it.
Yeah, because to a bacterium, a tiny scratch on a standard piece of industrial rubber or a microscopic pore in a plastic component isn't just a scratch.
Right.
It looks like the Grand Canyon to them. It is a massive, deep sanctuary where a pathogen can hide.
Yeah, they just set up camp.
Exactly. And when the washdown happens, the high-pressure water and chemicals might just skim over the top of that microscopic canyon, leaving a thriving colony of bacteria perfectly safe at the bottom.
That is an excellent way to visualize it. By utilizing FDA-compliant, non-porous polymers and specialized food-grade silicones, OnRobot is essentially paving over the Grand Canyon.
Wow. Yeah.
They completely deny the bacteria any structural foothold. There are no crevices for organic material to get trapped in, and there is nowhere for pathogens to take root.
That's brilliant.
And furthermore, these specific materials are formulated to resist degradation, so when they get hit with UV sterilization or those harsh chemical foams, they don't become brittle and crack.
Which would just create new canyons, right?
Exactly. They maintain their structural integrity indefinitely.
It is an incredible level of detail. And, the sources point out some really compelling real-world applications for this exact combination.
They do, yeah.
You could have this system deployed in a completely sterile laboratory environment, handling highly sensitive medical vials. Or, on the completely opposite end of the spectrum, it could be on a primary packaging line, gently manipulating fresh produce.
Which brings its own chaotic organic variability to the table.
Right. But in both scenarios, the pairing of the JAKA Cobot arm and the OnRobot gripper guarantees an absolute zero-tolerance approach to safety.
But, handling delicate materials like glass medical vials or fresh strawberries introduces another fascinating engineering challenge.
Because of the fragility.
Exactly. We have solved the sterility problem. We have a perfectly clean arm and a perfectly clean hand. But how does heavy industrial-grade machinery actually interact with these fragile items without just crushing them into dust?
Right, they're not lifting car chassis anymore.
No, moving from a state of sterility into actual physical execution requires a tremendous amount of finesse.
Exactly. I mean, human hands are incredibly delicate. When we talked earlier about humans being biological liabilities in a clean room, we also have to talk about human error in terms of physical handling.
Oh, fatigue is a huge factor.
Right. Humans get tired after an 8-hour shift in a hot clean room suit. Your grip strength calibration gets a little, sloppy.
And in these environments, dropping a tray of specialized medical vials isn't just a mess to sweep up. It is a catastrophic financial loss.
It's that $100,000 vanishing again.
Exactly. And it creates a massive contamination event that requires the entire room to be shut down and completely re-sterilized.
Right.
But this is where the micro-precision of the triple automation ecosystem truly shines.
Tell me about that.
The JK collaborative systems have micromillimeter repeatability.
And what does that actually look like in practice?
It means the robot utilizes highly advanced force torque sensors to literally feel the resistance of the object it is picking up.
Oh, wow. It can feel it.
Yes. It knows exactly how much pressure is required to lift a strawberry without bruising it, or to pick up a glass vial without cracking it. It applies the exact same delicate force along the exact same micromillimeter trajectory the first time it performs the action and the 10,000th time.
It never gets a hand cramp.
It never loses focus, and it completely eliminates the risk of human fatigue causing structural damage to delicate products.
Here's where it gets really interesting for anyone listening who operates in this space. If you're running a mid-sized facility right now, this is where the math suddenly changes entirely in your favor.
Absolutely.
We mentioned this earlier, but historically, achieving this specific level of flawless, sterile, micro-precise automation required a staggering capital investment. You had to buy multi-million-dollar rigid industrial infrastructure.
You essentially had to build the factory around the robot rather than bringing the robot into the factory.
Right, which meant only the absolute massive multinational conglomerate could afford to play in this top-tier space.
Yeah.
If you were a small, specialized manufacturer, you were effectively priced out of true sterile automation.
It was a huge barrier to entry.
But triple automation is taking this highly rated, certified hardware, the IP68 waterproof Cobots, the FDA-compliant non-porous grippers, and packaging them into intuitive, flexible solutions that don't require rewriting your entire business model.
They are allowing specialized, medium-sized manufacturers to automate safely, to do it swiftly, and to do it with absolute confidence. If we connect this to the bigger picture, it really is a paradigm shift in accessibility.
Totally.
They are taking something that used to be a massive, complex engineering headache, navigating strict cleanroom safety compliance, and they're making it simple and plug and play. It is precision engineering designed for the most demanding environments on Earth, but democratized for the SME.
So let's take a step back and look at the journey we've just been on. We started by exploring how the very philosophy of automation has to radically change the moment you step foot into a sterile environment.
Right, moving away from just speed and power.
Exactly. Triple automation has led a shift away from traditional metrics like simple payloads, focusing instead on creating a literal physical shield against human contamination.
The ultimate quarantine.
Yeah. We look deep into the hardware that makes that possible, specifically the JAKA Pro series and its IP68 rating, utilizing aerospace-grade sealing to ensure the robot can thrive in the brutal reality of caustic chemical washdowns without short-circuiting.
And we examined that vital handshake between the machine and the product. By integrating OnRobot's FDA-compliant, non-porous end-of-arm tooling, the ecosystem denies bacteria any microscopic canyons to hide in.
No more Grand Canyons.
Exactly. It ensures that the tool touching the product is just as rigorously sterile as the arm moving it.
All of which comes together to provide zero-tolerance safety. Paired with micromillimeter repeatability, it eliminates human fatigue, stops delicate products from being crushed, and protects the financial viability of a production line.
It's a complete game changer.
So what does this all mean for you? It means that the highest tier of precision engineering, designed specifically for the most demanding and unforgiving environments on the planet, isn't just locked away in the ivory towers of massive conglomerates anymore. The playing field has fundamentally shifted.
And I think that leaves us with a truly fascinating question to consider as we wrap up.
What's that?
Well, if the barrier to entry for flawless, contamination-free manufacturing has been lowered from multi-million-dollar rigid industrial setups down to these flexible, intuitive cobot ecosystems, how might that democratize innovation entirely?
No, that's a great point.
Right. Could the next major breakthrough in delicate, life-saving medicine or the next massive boom in specialized fresh food packaging come from a small local startup simply because they now have the robotic shield to safely produce it?
It's an incredible thought. The difference between the messy diner kitchen and flawless open-heart surgery is now just a plug-and-play system away. Something to think about the next time you see a perfectly sealed medical vial or a flawlessly packaged container of fresh produce.